Now the question number 21. Three unequal resistors in parallel are equivalent to a resistance is 1 ohm. If two of them are in the ratio 1:2 and if no resistance value is fractional, so that means it should not be fraction, then the largest value of three resistors in ohms is how much? So first of all, we will take here, let the three resistors are R1, R2 and R3. Now what happens in this case? So first of all here given R1 is to R2 is equal to 1:2. That means any two resistances we will take as 1:2. So then we will write like this. So let us consider R1 is equal to 1 into x and R2 is equal to 2 into x and R3 value I will write as R3. And also they gave equivalent resistance, that means R effective is equal to 1 ohm is given. And find the largest resistance of all these ones. So first of all, when the resistances which are connected in parallel here, so 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by R effective is 1 is equal to 1 by 1 into x plus 1 by 2 into x plus 1 by R3. So here 1 by R3 is equal to 1 by 1 minus 1 by x minus 1 by 2x. But here 1 by R3 is equal to LCM, we will take this one as 2x. So here 2x LCM means here 1 is there. So what I will write here, first of all 2x, and here x means minus 2, here minus 1. So 1 by R3 is equal to 2x minus 3 divided by 2x, and here R3 is equal to 2x divided by 2x minus 3. So if we want to calculate all the three resistances, so first of all, if x is equal to 1, what happens here? R1 is equal to 1 into x, that is 1. Then R2 is equal to 2 into 1, that is 2 ohms. Then R3 is equal to, that is 2 into 1 divided by 2 into 1 minus 3 is equal to 2 divided by 2 minus 3, we will get minus 2. That means negative value we are getting. So that's why x is equal to 1 is wrong. Suppose if we are taking x is equal to 2. So R1 is equal to x value means 2 ohms. Then R2 is equal to 2 into 2. That means 2 into 2 is equal to 4 ohms. Then R3 is equal to 2 into 2 divided by 2 into 2 minus 3. So here 4 divided by 4 minus 3 is 1. Here 4 ohms. But here two resistors are same. So that means here no larger resistance. So that's why here this is also wrong. Suppose if x is equal to 3. So R1 is equal to 3 ohms. R2 is equal to 2 into 3, that is 6 ohms. Then R3 is equal to 2 into 3 divided by 2 into 3 minus 3. 2 3s are 6 divided by 2 into 3. 6 minus 3 is nothing but 3 is equal to 2 ohms. So it is correct, but here no fractional value and also no equal values. So 3 ohms, 6 ohms and 2 ohms. Which answer is correct here? 6 ohms is the maximum resistance we are getting. So that means the option is B is correct. Now the question number 22. Consider the two following statements A and B and identify the correct choice given in the answers. So A, Doodle's thermogalvanometer is suitable to measure the direct current only. B, Thermopile can measure the temperature differences of the order of 10 to the power of minus 3 degrees centigrade. So first of all, we will take A. Doodle's thermogalvanometer is suitable for measuring direct current only. So that means DC current, they're telling that is DC current. So that means what happens here? Actually, Doodle's thermogalvanometer is nothing but thermogalvanometer. It is used to measure very small amounts of alternate currents. It has very small resistance. So that's why option A, this one is wrong. And thermopile can measure temperature differences in the order of 10 to the power of minus 3 degrees centigrade. Thermopile is an arrangement of thermocouple in series used to generate thermoelectric current or for detecting and measuring the radiant energy. So that means radiant energy is nothing but that is 10 to the power of minus 3 degrees centigrade. So that means option B is correct. So here this is B is correct, but A is wrong. So that is the question number 22. Now question number 30. When NPN transistor is used as an amplifier, what happens here? Actually, transistors can be considered as base collector emitter. Base collector emitter, here I will write here base and here collector and here emitter. So if the base is taken as positive, means the electrons which are moving from base to the collector itself. So that's why I wrote the diagram like this. But here, so which option is correct here? Electrons are moved from base to collector. Why from base to collector? If the base is given as positive, the electrons are moving from base to the collector. So that's why option A is correct. Now the question number 23. A galvanometer having a resistance of 50 ohms gives a full scale deflection of a current 0.05 amperes. The length in meter of a resistance wire of cross section 2.97 into 10 to the power of minus 2 centimeter square that can be used to convert the galvanometer into ammeter, which can read as a maximum of 5 amperes of current, is how much? But specific resistance of wire is given 5 into 10 to the power of minus 7 ohm meters. So which one we want to calculate here? That is the length we want to calculate. So how much amount of length of the resistance we are using to get the current of 5 amperes. So first of all, what are the given values we will write? So galvanometer resistance, that is given 50 ohms, and current which passes through the galvanometer, that is 0.05 amperes, and area which is given 2.97 into 10 to the power of minus 2 centimeter square, and 2.97 into 10 to the power of minus 6 meter square. Why? Because centimeters is 10 to the power of minus 4. So here minus 6 meter square, and here to get the amount of current, that is I is equal to 5 amperes, and the specific resistance that is given 5 into 10 to the power of minus 7 ohm meter. So which one we want to calculate here? Resistance. So resistance R is equal to how much amount of resistance? That is Ig into capital G divided by I minus Ig. So now the substituting the values 0.05 current through galvanometer and resistance in the galvanometer 50 divided by 5 amperes of current we have to send here minus 0.05 is equal to 25 divided by 4.95 is equal to 2500 divided by 4950. So then what happens in this case? On cancellation of this one, that is 50 50s are and 99s are. So this is the resistance we are getting. But which one we want to calculate? Length. So resistance is equal to rho L by A. So L is equal to R into A by rho. So area we know 2.97 into 10 to the power of minus 6 divided by area we know, and specific resistance also we know 5 into 10 to the power of minus 7 into resistance value 50 divided by 99. This one we know here. But one thing remember, here 5 tens are 50 Then what happens in this case? Simply 10 divided by 99 into 10 divided by 99 into 2.97 into 10. Why? Because minus 7 here, minus 6 plus 7, that is 10. So 99 how many times here? 0.03. So here 100 multiplied with this one, how much we are getting? 3 meters. So a length of the resistance which can be used to get the 5 amperes of current, how much that length is? 3 meters is the answer. 3 meters is the answer. Now the question number 24. A coil of 1000 turns and 500 centimeter square as its area. The plane of the coil is placed at right angles to the magnetic field of induction 2 into 10 to the power of minus 5 Weber by meter square. The coil is rotated through 180 degrees in 0.2 seconds. The average EMF induced in the coil in millivolts is how much? So first of all, given number of turns in the coil is 1000 and area that is 500 centimeter square. This is 500 into 10 to the power of minus 4 meter square, and here given when it is placed perpendicular to the magnetic field. So initial angle we will take that one initial angle as theta is equal to 0 degrees, and where the magnetic field of induction that is 2 into 10 to the power of minus 5 Weber by meter square, it is nothing but Tesla. When it is rotated through an angle 180 degrees in how much time period here? Delta t is equal to 0.2 seconds. Then which one we want to calculate here? Average induced EMF in the coil. We know that phi is equal to N into BA cos theta. This is the formula. But which one we want to calculate here? That is average induced EMF. So that means E is equal to delta phi divided by delta t. So what is delta phi? Is nothing but phi 2 minus phi 1 divided by delta t. So what is phi 2 here? N into B into A cos 180 degrees minus N into B into A cos 0 degrees divided by delta t is nothing but 0.2. So here cos 180 minus NBA, here cos 0 1, that means minus NBA divided by 0.2. So what happens here? 2 times NBA divided by 0.2. Now substitute the values here, but here my E is nothing but induced EMF is nothing but negative rate of change in flux. So that's why I will take here minus, and I will take this one as minus, and here totally I will take this one as minus. We will get plus. So that means plus 2 into 1000 into N. B is nothing but 2 into 10 to the power of minus 5 into area 5 into 10 to the power of minus 2. Why? Because 500 10 to the power of minus 4, 5 into 10 to the power of minus 2 divided by 0.2. So on calculation of that, 10 into 10 to the power of minus 3 volts. So here 10 minus 3 is nothing but millivolts. So which option is correct here? Option B is correct. Now the question number 25. A long straight wire carrying a current of 30 amperes is placed in external uniform magnetic field of induction 4 into 10 to the power of minus 4 Tesla. The magnetic field is acting parallel to the direction of current. The magnitude of the resultant magnetic induction in Tesla at a point 2.0 centimeters away from the wire. So here we want to calculate the resultant magnetic field. So first of all, a straight current carrying wire which carries a current of 30 amperes and the magnetic field of induction which must be placed, that is 4 into 10 to the power of minus 4 Tesla, and the magnetic permeability, that is mu naught is equal to 4 pi into 10 to the power of minus 7 Henry per meter, and which is placed at 2.2 centimeters. So that means radius, the distance is equal to 2 centimeters. That can be written as 2 into 10 to the power of minus 2 meters. But initially I will take the magnetic field B1 is equal to 4 into 10 to the power of minus 4 Tesla. This one I will take as number 1. But when the magnitude of resultant magnetic field in Tesla at a point 2.0 centimeters away from the wire, that I will take as B2 is equal to mu naught I divided by 2 pi r. That is 4 pi into 10 to the power of minus 7 into current is 30 amperes divided by 2 into pi into 2 into 10 to the power of minus 2. Here 2 cancel, pi 4 cancel, and here that is 30 into 10 to the power of minus 7 plus 2. So 30 into 10 to the power of minus 5 or 3 into 10 to the power of minus 4 Weber per meter square or Tesla. But here I want to calculate the net magnetic field. So this magnetic field is parallel to the current, but this magnetic field is present at 2 centimeters, that is perpendicular. So that means what happened, there will be some resultant is there. So that means B is equal to square root over B1 square plus B2 square is equal to square root over 4 into 10 to the power of minus 4 whole square plus 3 into 10 to the power of minus 4 whole square is equal to square root over 4 square is nothing but 16, 3 square is nothing but 9 into 10 to the power of minus 8. So this is 25 into 10 to the power of minus 8, that one, and here 25 root is 5, 10 to the power of minus 8 root is 10 to the power of minus 4 Tesla. So which option is correct here? 5 into 10 to the power of minus 4 Tesla. Option C is correct. Now the question number 26. Two ions having the masses in the ratio 1:2 and charges which are in the ratio 1:2 are projected into uniform magnetic field perpendicular to the field with the speeds are in the ratio 2:3. The ratio of the radii of the circular paths along which the two particles moves is how much? So first of all, what are the given ratios are given here? M1 is to M2 is equal to 1:1. And charges Q1 is to Q2 is equal to 1:2, and speeds are in the ratio V1 is to V2 is equal to 2:3. But when the charge which is projected into the uniform magnetic field, the radius R is equal to mv by bq. But here B is constant. Why? Because all this charge which is projected into the magnetic field. So which are the variations here? That is simply I will write R1 divided by R2, that means we want to calculate the radii, is equal to mass M1 divided by M2 into V1 divided by V2 into, here inversely proportional, no, Q2 divided by Q1. What I am taking here, R1 divided by R2 is equal to M1 divided by M2. M1 is how much here? 1 divided by 1 into V1 divided by V2. What is that V1 divided by V2? 2 by 3 into charges Q2 by Q1. So that means Q1 by Q2 here. Q2 by Q1 is nothing but 2 by 1. So here R1 divided by R2 is equal to 2 2s are 4 divided by 3. So here ratio R1 is to R2 is equal to 4:3. So which option is correct here? That option is A is correct. So that means this is the solution for question number 26. Now the question number 27. Consider the two following statements A and B and identify the correct choice given in the answers. A. In photovoltaic cells, the photographic current produces is not proportional to the intensity of incident rays. And B. In gas filled with photoemissive cells, the velocity of photoelectrons depends on the wavelength of the incident radiation. So first of all, we will take A. In photovoltaic cells, the photographic current produced is not proportional to intensity of incident light is wrong. Why? Because it is proportional to intensity of incident light. So here that is option A is false. False. In a gas-filled photoemissive cells, the velocity of photoelectrons depends on wavelength of incident radiations. So it is absolutely correct. Why? Because the incident wavelength, which only decides how speed the radiation enters into the photoemissive cells. So that's why option B is true. So which option is correct here? Option D is correct. Now the question number 28. When radiation of wavelength lambda is incident on the metallic surface, the stopping potential is 4.8 volts. If the same surface is illuminated with radiation of double the wavelength, then the stopping potential becomes 1.6 volt. Then the threshold wavelength for the surface is how much? So first of all, we will write the formula for stopping potential. So that means here stopping potential, that is V0 is equal to H into C divided by E times 1 by lambda minus 1 by lambda naught. So that means lambda naught is the stopping, that is lambda naught is the threshold wavelength. So first of all, in first case what happens here, wavelength lambda, metallic surface, stopping potential is 4.8. So that means 4.8 is equal to Hc divided by E into 1 by lambda minus 1 by lambda naught. This is the equation number 1. In second case, if the radiation of double the wavelength and stopping potential is 1.6. So 1.6 is equal to Hc divided by E times 1 by 2 lambda minus 1 by lambda naught, that is the second one. So that means what happens in this case here, 1 divided by 2. So that means 4.8 divided by 1.6 is equal to HCE both are cancelled. So the remaining one is 1 by lambda minus 1 by lambda naught divided by 1 by 2 lambda minus 1 by lambda naught. So here these two gets cancelled, we are getting the 3 here. Then lambda naught minus lambda divided by lambda into lambda naught into 2 lambda into lambda naught divided by lambda naught minus 2 lambda. So here lambda naught cancel. 3 is equal to lambda naught minus lambda divided by lambda naught minus 2 lambda. Here 3 is equal to lambda naught minus lambda divided by lambda naught minus 2 lambda. Here multiplied with here 2 is remaining. So then what happens here, cross multiplication, 3 lambda naught minus 6 lambda is equal to 2 lambda naught minus 2 lambda. So here 3 lambda naught minus 2 lambda naught is equal to minus 2 lambda plus 6 lambda. So on subtraction of this one, lambda naught is equal to plus 4 lambda. So which option is threshold wavelength for the surface is, answer is 4 lambda is the option. So option is here, B is the option. Now the question number 29. The mass defect in a particular nuclear reaction is 0.3 grams. The amount of energy liberated in kilowatt hour is velocity of light, that is 3 into 10 to the power of 8 meters per second. So here the mass defect is given. So first of all, mass defect is nothing but delta M is equal to 0.3 grams is nothing but 0.3 into 10 to the power of minus 3 kilograms, or otherwise 3 into 10 to the power of minus 4 kilograms. And velocity of light, speed of light in vacuum, 3 into 10 to the power of 8 meters per second. But actually energy liberated according to Einstein's mass energy equivalence, E is equal to delta M into C square. So what is delta M here? 3 into 10 to the power of minus 4 into C, 3 into 10 to the power of 8 whole square. So that is nothing but 3 into 10 to the power of minus 4 into 9 into 10 to the power of 16. So then what happens in this case? 9 into 3 is 27 into 10 to the power of minus, that is plus 12 joules. But here amount of energy liberated is kilowatt hour, required kilowatt hour. So kilowatt hour is nothing but 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules. But 1 joule is equal to how much? We will substitute here. That is 27 into 10 to the power of 12 divided by 3.6 into 10 to the power of 6. That is kilowatt hour. So on calculation of this one, 7.5 into 10 to the power of 6 kilowatt hour. So which option is correct here? Option D is correct.